probability rules. This is part of an Applied Bayesian Statistics course at Virginia Commonwealth University. All right, so we've been building up probability, and this is what we know so far. We have a sample space, we denoted S. We have an event, E, its complement, denoted E with a superscript C. And then we have the union, which is E, sort of a U or a cup, F. The intersection is E intersect F, or I would say it's a cap, F. And then we have the empty set, and then we did the axioms of probability last time. Probability of the sample space is 1. The probability of any event is greater than or equal to 0 for every single event in S. And if we have a set of events then that don't overlap, then we can find the union of the probabilities just by adding them together, adding the probabilities together. And what we want to do is create some more rules. That way we can navigate probability easier and find probabilities much, much easier than without these rules. All right, so here we go. What is the probability of a complement? Okay, so here's E, here's S. Everything outside is E complement, right? That's what we had from before. Well, we know that the whole square is equal to 1. Okay, and this is not by any means a rigorous proof, but I'm just giving you the sketch of it, okay? So we know the whole thing's equal to 1, which is equal to the probability of S. We know that E union E complement is equal to S. So we're now using that third rule there. And we know that E union E complement does not overlap, right? So that means we can just add those two together. Well, if we add those two together, we can then do a little bit of algebra by moving this to one side and move things around. And you can show that the probability of E complement is 1 minus the probability of E. It's pretty easy. Okay, and this is the argument for it versus just saying, here's the rule. Okay, what about the probability of a union, right? We have E and F, and we've just dumped all their outcomes into one big set here called E union F. So what's the probability of this? Well, we have to pay attention. Okay, so it's going to be the probability of E and the probability of F, but the problem is that overlaps. And that's where that rule where it says they don't overlap comes into play. Here they overlap, so what do I do? Well, that means this intersection has been counted twice. The outcomes that are in F, it was counted there, and it was counted as an outcome in E as well. So we don't want to keep that in there, so what we would do is just subtract it out. Okay, so we subtract out the intersection because the intersection is double counted. Okay? And if we were interested in the intersection of E intersect F, well, just do a little bit of algebra and you'll see the probability of E intersect F is probability of E plus probability of F minus their union, the probability of the union, and that works out as well. Okay, so these rules are pretty easy. So I'm going to list down here everything we've got. We've got the sample space, we've got an event, we've got a complement, we've got the union, the intersection, the empty set, the axioms of probability. Now we have the complement rule, and we have the rule for working with unions and a rule for working with intersections. And we're going to come up with some more rules as we go along here, because what we're trying to do is ultimately get to Bayes' rule, which depends on a lot of these. So we have to know our notation, and we have to know how things chain together in order to make all of this work. But we're going to find out more in the next video. See you there.